Chapter 7, Lesson 1. Chapter 7 starts getting into exponentials. This is specifically graphing exponentials. We've done something similar to this before, as far as like you're really just filling in a table and then graphing. So a couple things before we get into the example. The way that your problems are going to be set up will look similar to y equals ab to the power of x. Your x is what you are going to pick values for to plug into, and then you're ultimately solving for y, which is where your x and y coordinates are coming from that you are going to graph. Then kind of the two types of graphs that you're going to see are exponential growth and exponential decay. So an exponential growth is going to be a graph that's increasing as it goes, and then exponential decay is going to be something that is decreasing as it goes on. Some of the other vocabulary up here we'll talk about whenever we get into the actual questions. So these are kind of what your graphs are going to look like. So this is the parent function, is just y equals b to the power of x. It's a type of graph that is going to specifically cross through 0, 1, and then continue to increase. So we've looked at different types of graphing before, and like how h and k and different values affect your graph. There's a similar process for this as well. The other thing that we have not talked about a whole ton is what an asymptote is. An asymptote, and on this case it's the x-axis, it is the number or axis that your graph is getting really, really close to, but it's never actually going to touch. So I know this looks like it's touching the x-axis, but if you were to look at the numbers, so like if we were to look at this point, if that was x is -7, the y value might be 0.00004. It's going to be really close to 0, but it's never actually going to touch 0, and it's specifically also never going to cross over into the negatives or actually have a 0 or an x-intercept. So getting into example 1, this is kind of just your parent function of your graph to see what these types of graphs look like. So it's going to tell you to graph y equals 4 to the power of x, and then to state the domain and range. So just as a review really quickly, your domain is your x values, specifically from left to right. Your range is your y values, specifically from bottom to top. So for this question, the x values, and again, you can pick other x values. The x values that I would choose to plug in would be -2, -1, 0, 1, and 2. You could also go to -3 to +3, but I would make sure you have some negatives, a 0, and then some positives, so you see both sides of the graph. So you are then plugging in these values into your x in your problem and then solving. You can do that using a calculator. Some of these you should know without a calculator. So for this first one, I would have 4 to the -2nd power. 4 to the 2nd power is 16. Because it's negative, this would really end up being 1 over 16. Then 4 to the -1 power would just be 4. Because it's negative, I would have 1/4. Again, you can use decimals or you can use fractions. Then when I have anything to the power of 0, it's going to be 1. 4 to the 1st power is 4. 4 to the 2nd power is going to be 16. So I am then graphing this -2, and then 1/16 is going to be close to my x-axis, -1, 1/4, also kind of close, 0, 1, 1, 4, and then 2/16 is going to go off, and it would be up here if we would continue our graph. So again, this line right here is never actually going to touch your x-axis. So if you were like put in -3, it's just going to keep getting smaller and smaller, but never be 0 and never touch 0. So your next part of this question asks you to state the domain and range. So your domain is left to right. So as I'm looking on this side and moving over, this is going to touch everything on my x-axis going to the left, and it's going to eventually touch everything to the x-axis going to the right. So one of the ways we wrote this earlier this year is -infinity to +infinity. That's also the same as all real numbers. The -infinity, +infinity is something that you will more so see, especially as you get higher into your math classes. Then your range. So the lowest that your graph is going to go will be to 0. It's not going to go below 0 at all. So it's going to go to 0, not touch 0, but close to it. And then it will continue to go up to infinity. So would be like all positive numbers. Whenever some of you learned how to write this, you may have learned it as y is greater than 0 would be another way that you could potentially write that. So for example 1, your answer is your graph, and then your domain and range. So that's kind of what a normal exponential graph looks like. Then looking at example 2, and before we actually do example 2, this is something that you've kind of seen before. So this top kind of formula is what all of these things do to your graph. So the H again affects the horizontal shift. So it's going to move your graph left to right. The K on the outside is a vertical translation. So it's moving your graph up or down. The A value, if it's negative, and this is where this is coming from, if the A value is negative, your graph is going to be reflected. And then the A value is also going to tell you if your graph is being stretched vertically or if it's going to be compressed vertically. So again, like a normal graph would look like this. So if it's compressed, it's going to have more of a sharp turn to it, versus stretched is going to be almost closer to a straighter line. So looking at example 2, and you do not have to set up your tables like this. This is kind of just to break it down to show you the process of what's actually happening, instead of having to do like both steps at once. So this is asking you to graph the function y equals 3 to the power of x minus 2. The -2 on the outside right here is your k value. K value tells you vertical shift. So where this helps you is you should kind of already know by looking at this how it's going to affect your graph. So if it is a -2, that means your entire graph is going to move down 2 spaces. So it's going to look very similar to example 1, but instead of being at 0 and not touching 0, it's now going to go down and not touch -2. So that's kind of where that comes from. So again, I'm going to pick values from -2 to +2. You can start with -3 and go to +3. There's not enough space for that, but you can add them in if you want to. So for this first part, when I do 3 to the -2nd power, I know 3 to the 2nd power is 9. Because it's negative, I would make it 1/9. And I'm going to do this first column all the way down and then go through the subtracting part. Then 3 to the -1st power would just be 3. Because it's negative again, would be 1/3. Anything to the 0 power is 1. 3 to the 1st power is just going to give me 3. And then 3 to the 2nd power will give me 9. So your points are there's kind of a pattern with this. There's a reflection. Then for this next column, it's just taking everything you got from that column and subtracting 2 from it. So this is where, instead of using fractions, if you want to switch to using decimals, you are more than welcome to. Either way, it will give you the same answer. So 1/9 minus 2 is going to give you, and I just plug these into my calculator to get answers. 1/3 minus 2 is going to give me -1.76. 1 minus 2 is going to give me -1. 3 minus 2 is going to give me 1. And then 9 minus 2 will give me 7. So the ordered pairs that I'm graphing are this first column and then the last column. So I'm graphing -2, -1.89. So again, you will notice these numbers. So the down 2, this is going to get as close to -2 as it possibly can without actually going over -2, because that's my asymptote and that's where it's never going to cross. So graphing this first point, I'm going to go over to -2 and then down to -1.89, then -1, -1.67, then 0, -1, 1, 1, and then 2, 7. So again, same shape to your graph. So this is where it's important to be sure of where your graph is specifically stopping and where it's going. So your graph is never going to cross -2. And I know that because it shifted down 2 spaces. So your next part is stating your domain and your range. Your domain, again, is just going to be -infinity to +infinity. So it's going to touch everything on the x-axis. Again, also all real numbers. Your range is a little bit different this time. So because it moved down 2 spaces, it's now going to be from 0 to 2, going from 0 like we did on the last example. It's now at -2 is the lowest that my graph is going to go, and then the highest my graph will go is to +infinity. So you could also write that as y is greater than -2, not equal to, just greater than, because again, it's never actually going to touch -2 or cross -2. Then example 2, part B, has a different type of shift in this. So the last one, the -2 was a large number that was not part of the exponent, which was your k value. Now the -1 right here in your problem is part of your exponent. So this is your h value. Your h value is a horizontal shift. And this is, again, kind of opposite of what you think it is. So I have y equals 2 to the power of x minus 1. So the formula itself is actually x minus h. So all I'm looking at is the 1 itself. So this tells me that my graph is going to shift to the right 1 place. So again, same process as all the other ones. I'm plugging in values for x and then solving. You'll notice there's not 2 columns here. Part of that is because it's an exponent, or like your -1 is added to your exponent, you really have to do that in one step anyways. So there's not necessarily another column. And again, on example 2, part A, you don't really have to do that middle part of your table. You could just go from original, plug the whole thing into your calculator, and get your answer. It's important to just make sure that whenever you're plugging in, you're paying attention to whether it's actually plugging into the exponent versus a whole number, because it's going to affect how your graph is actually shifting, if it's shifting up or down or left or right. So plugging these points in, when I plug in -2 to this, I would really end up with 2 to the -3rd power, which is equal to 0.125. And again, just using calculator, if you plugged in -1 for your x value, you would end up with 2 to the -2nd power, which is 0.25. This would end up being 2 to the 0 minus 1 power, which is 2 to the -1st power, which will give me 0.5. 2 to the 1st power minus 1 is going to give me 2 to the 0 power, which is equal to 1. And then 2 to the 2nd power minus 1 would give me 2 to the 1st power, which is just going to equal 2. Again, some of those you can do in your head or use a calculator, check yourself. Now I am then graphing. So my graph is not shifting up or down at all. My values are still going to get as close to 0 as possible, but not cross 0. It's just my graph is going to shift over to the right now versus crossing at 0, 1. It's shifting over, and that 1 point is going to now be at 1, 1. So it's shifting over, and you can kind of see that right here in your chart. So graphing -2, 0.125, -1, 0.25, 0, 0.5, 1, 1, and then 2, 2. Your graph will then look like this. Again, not touching 0 or crossing 0. So this point right here is kind of the point where you can see like your original graph on both of the other ones crossed at 0, 1. But that point shifted over to the right one to now be at 1, 1. So that's kind of where you can see your shift. Your domain again, and your domain on 99% of these is going to be the same. Is -infinity to positive infinity. It's going to touch everything on the x-axis. And then your range, the lowest your graph goes is 0. And then the highest your graph is going to go is to positive infinity. So your answer is your graph and the stating domain and range. I would make a table. It's going to make your life a lot easier. It also helps me see your ordered pairs to know that you're actually graphing them correctly, because there are specific points that it crosses. You can't just sketch a shape on a graph and hope that it crossed the correct points. It needs to cross at specific points in order to get full credit on a quiz or a test for something like that.